morning, everyone. Welcome to today's Upskill workshop. My name is Sharda Kalanidhi. I'm a technical director of the WiDS Datathon. I've had the privilege of being involved with the Datathon, particularly with the dataset preparation. And today I will be a workshop host. Today's workshop will be presented by Kelly Hoang, Associate Director of Data Sciences at Gilead Sciences. Kelly completed her PhD in information sciences with focus in natural language processing, machine learning, and their applications in biomedical domain from the University of Illinois at Urbana-Champaign. She currently works as a data scientist in the oncology group, advanced analytics department at Gilead Sciences, where they develop AI/ML products to support clinical trial development and operations. Kelly was also super helpful when we were going through various cuts of the data set in the early stages of data set preparation. She has particular expertise in the data, and we thank you for your help and deep insights. Kelly will deliver a hands-on workshop, data processing and transformation in machine learning, a real-world data use case, utilizing the WiDS Datathon April dataset. If you have any questions for Kelly during the workshop, please enter them in the Q&A section of the webinar. Kelly will answer questions live after workshop presentation. Over to you, Kelly.
Thank you, Sharada, for the warm welcome. So I'm going to share my screen right now, and please let me know if you can see my presentation slide. And let's switch to the presentation mode. Can you see the slide right now?
Yes, we can see it, Kelly.
Thanks. Thanks, everyone. My name is Kelly Hoang. I am Associate Director Data Scientist from Gilead Science. We are a biotech pharmacy company, and we're known for medicines that curb HIV, hepatitis B and C, and we are upcoming biotechs in oncology area. And today it's my honor to have all of you and to present a workshop with topic data preprocessing and transformation in machine learning, and in the use case of WiDS Datathon 2024. So the agenda of the workshop today, first I will briefly introduce myself and why I'm here having this workshop with you guys. And then we talk a little bit about learning objectives, what we hope that you can get out from this upskill workshop. And then we discuss about data preprocessing and transformation, what it is and why it is important. And then we also discuss a little bit about data preprocessing and transformation with real-world data, which is a very specific kind and special kind of data in the use case of WiDS Datathon 2024 dataset. And finally, but also is the most exciting part, is to do some hands-on practice to perform data preprocessing steps and transformation techniques on Google Colab. So I know that this is upskill workshop, but the topic is today is data preprocessing and transformation, which is a very basic topic. So the technical part of this workshop will not that be complicated, but it's not meant to be, the workshop is not meant to be a technical workshop, but we think like this might be a good opportunity to revisit such a basic but very fundamental topic in machine learning, especially when you know, like the WiDS Datathon 2024 Challenge 2 just launched like at the beginning of this month. So we think that this might be a good opportunity and maybe a good starting point to revisit such fundamental topic, and maybe it can be helpful for some of you who might be interested in to take part in this Datathon challenge from WiDS. So a little bit introduction about myself. So my life is all over the place. I moved from one country to another. I did my bachelor degree in computer science in my home country in Vietnam. Then I went to UK and did my master degree in information systems. And then I went to Singapore and worked as for my first job as a business intelligence engineer. And then I moved to the US and did my PhD in information sciences and start my data science career at Gilead. So the reason why I would like to share these journeys with you guys, because among these years, a lot of different areas just came up in my journey, right? Computer science, information systems, business intelligence, data science, information sciences, they all sound very similar. They are, but they also very different because they require slightly different skill sets. But then among all of these areas, there's one consistent theme just emerge from them, which is I'm doing something related to data, right? Computer science and information system give me the technical skill set that I need to analyze the data. And business intelligence and data science is to really deep dive into understanding different data set, conveying, try to like get our stories, different stories from the data. So I hope that it's explained why I end up with where I am right now and having this data science, upskill data science workshop with you guys. So the learning objectives of our workshop today, of course, we want hope that we will give you better understanding of what is data preprocessing and transformation and why it is important in machine learning development pipeline. And again, this is such a basic topic. However, I cannot emphasize enough how important it is. And we also want to give you an opportunity to hands-on practice on data preprocessing steps and transformation techniques through the use case of WiDS Datathon 2024 dataset. So first, let's talk about what is data preprocessing and transformation. So I'm sure that maybe many of you already familiar with the pipeline that I show on the figures here. Basically, it is the pipeline from end to end, the development of a machine learning model. So you start with a data set, and then you do some data cleaning, feature engineering if it's traditional machine learning, or some kind of transformation if it's a deep learning model, and then you have a training data set. You feed into a learning algorithm and train your model. And then you have test data set. You run the trained model on the test set to evaluate the model accordingly. So data preprocessing and transformation is the procedures like somewhere in between data cleaning and feature engineering here. But basically, it's the procedures to transform raw data into more appropriate form so that it can be ready for downstream machine learning steps. Even though, again, even those data processing and pre-processing and transformation is just like one or two bubbles, one or two circles in this pipeline, but it's so important. In fact, I don't know how about your experiences, but for my experiences working on tons of projects, machine learning and natural processing projects, data cleaning, pre-processing and transformation often like take up like 70% of my time. So I cannot emphasize enough how important this process is. And then, yeah, now let's, why it's important. Basically, the learning algorithm, the machine learning algorithms that learn from data are just simply statistical equations, operate on the values in your data set, nothing fancy about them, right? And there's an idiom about if garbage go in and garbage comes out. And it's really applied in this case, regardless how great your machine learning model is, how great your algorithm can learn, your project, your machine learning pipeline can only be successful if the data going into the algorithm, going into the machine learning model is in high quality. So let's discuss a little bit about like what are the most basic data pre-processing tasks. So if you look up data pre-processing in machine learning, you will find a lot of figures similar to this on the internet. Basically, data pre-processing contain four basic tasks: data cleaning, data integration, data transformation, and data reduction. And in our workshop today, I'm more focusing on the data cleaning and data transformation part of it. So data cleaning is the process of removing incorrect data, incomplete data, or inaccurate data from the data set. So it can be like cleaner in a sense to fit into your machine learning model. Data integration is a process of combine. Basically, you try to enrich your original data by combine your original data set with something else that might be helpful and informative from your machine learning model. We're not going to talk about data integration in this workshop, but I'm sure that the data set that we are using for this this workshop, the WiDS Datathon 2024, Sharada, who's the host of our workshop today, she did an amazing job of like integrating the original data set with like external data set to enrich and to give you guys like more information and more data to play with. Data transformation is something we will touch on in this workshop. Basically, we want to change the original format of your data to some kind of like formats that machine learning model will take, right? Because for example, deep learning model, neural network model only understand numerical data. So if you have text data, you need to have some technique to transform your text data to numeric representation, so-called embeddings, in order for the neural network to understand. And finally, data reduction. This process helps to reduce the volume of the data because we know that not everything in your data set will be helpful, will be informative to train your machine learning model. So there are some analysis. You need to basically perform some analysis in order to understand your data set and make a decision to reduce the data set without affecting the results of the machine learning model. So let's discuss a little bit about data preprocessing in real-world data use case. So real-world data in medicine is a concept in biomedical domain and in medicine, which means for data derived from a number of different sources about patient population in real-world settings. It including but not limited to like electronic health records or health insurance claim, clinical registry, and patient surveys. So because of the nature of real-world data, it's come from different data sources, and each data source each system have different way to maintain, to store the data. Therefore, the format of data are very like diverse, right? And that is the reason why real-world data tends to more messy and have quality issues in it. And the task that data preprocessing, therefore data preprocessing required for real world data often lie more incentives than others. So WiDS Datathon 2024, this year Gilead is the main sponsor of WiDS Datathon 2024. We collaborate with WiDS Datathon team to provide the data set that we can use in for the Datathon, and this is a real-world data set which contains information about patient demographics, diagnosis, and treatment information. And we also provided insurance information about the patient, and these are the patient who was diagnosed with breast cancer, and more specifically, patient diagnosed with triple-negative breast cancer, TNBC. TNBC is one of the most aggressive type of breast cancers. Patients who diagnosed with TNBC tend to progress their disease like faster than others and in the need of being treated more urgently than others patients. So this data set originally was from HealthVarity, one of the largest healthcare data ecosystem in the US. And again, as I mentioned before, Sharada did a very great job of enriching it with the third-party geodemographic data to provide views into the socioeconomic aspect that may contribute to health equity. And the challenge task is you will be asked to develop a machine learning model to predict the duration of time it takes for patient to receive the treatment for their diagnosis. So again, it's a kind of like regression task. So with that, we will move to the more exciting part of the workshop, which is the hands-on practice on Google Colab. And what you need to perform this is the link to the Google Colab that we will share after the workshop today, and also the data file that we are using for the datathon. And these data file, including training and test set, are already uploaded on this Kaggle, that WiDS Datathon 2024 challenge, second challenge on Kaggle page. All right, so I will switch gear to our Google Colab page. So this is a Google Colab page that we created for this workshop. Basically, we will demonstrate some of the most basic data pre-processing steps and also data transformation techniques that you can perform prior to your machine learning model development. So again, here is just some brief information about the learning objective of the notebook, and also the description of the WiDS Datathon dataset that we are going to use in this workshop. So first thing I just want to highlight is that I am using Google Colab Python 3 for this in this notebook. So if you want to rerun the notebook afterward, make sure you have the right setting for it. And then also, I already upload the training set from WiDS Datathon and also the test set here. So it's they basically ready to be used. All right, so let's go to the first step. First step is always like import the libraries that we need to perform to run our notebook. And here I just use some very common, popular, and basic library that I'm sure that many of you know how to use them maybe already expert of these. We have NumPy libraries to deal with kind of like numeric data, Pandas to represent and store data in kind of like tabular format. Seaborn is a very pretty popular library and package used to plot, do some graphic visualization on top of your data. And Scikit-learn is another popular library used to pre-process data. All right, so I just run this self to basically import all of these library that I'm going to use into this notebook. And the next step is to import your data and perform some initial analysis. And again, I would say this is the most like time-consuming but most exciting steps during the data pre-processing and transformation, like to perform initial analysis. When you are handed a new data set, you know nothing about it. So it's always, I think it's always like interesting to really deep dive into your data set and perform some like very basic analysis, try to understand what is in it, what kind of like story that we can tell from this data set. And I found that this exercise is so important and it's so fundamental and essential for you to decide what would be the data processing step that you should perform, and what kind of transformation that you need to do for your data set. So with that, the first thing is just to import your data set into different, basically we call data frame using Pandas package. Data frame is just basically tables, right? And in here, this function, this command basically try to read the CSV file, the Excel file, and put the data into train table and test table. So it's look like this when you import your data into a Pandas table or data frame. You have rows and you have columns. The rows are the record. Each row is one patient record, and the columns are the features or the characteristic that tie to that particular patient. And let's see the next step is let's see how large is our data set. So basically, I just print out the number of rows and columns in training set and testing set to get a sense of like how big of the data that we are dealing with, right? So for the training set, we have in total like almost 13,000 rows with 83 columns. And for the test set, we have almost 4,000 rows and 33 columns. So this look good for me. That means we have a decent kind of like training data that we can use to train the model. And the number of features, basically the number of columns from the test set and the train set are like aligned with each other. And next thing I wanted to know, okay, what are the columns in our data set, right? We have 83 columns. That's quite a bit of information. What are they? How they look like? So let's deep dive into that. So Pandas, the reason why that package is so popular because it's not only be able, let us be able to represent the data in tabular format, which is very easy to understand and interpret. It have a lot of built-in functions that you can just call and then print out whatever you need to for your analysis of data, right? For example, this info.info is one built-in function from Pandas so that you can just print out all the column name, the type of those columns, and basically the distribution, the empty value and non-empty value of those columns. So if you just run this one single command, it will show you, okay, here's a list of columns in our training data set. And for example, you have the race information of the patient, and about 50% of this column are non-null value. That means it has some values in it, and the other remaining half, we don't have any value. So again, this kind of like initial analysis give you an idea of, okay, what is the quality of my data set, right? What are the columns, the fields that we should pay more attention to during the data preprocessing and transformation steps. So I see that Ray is missing quite a bit of data. BMI is something also interesting. BMI is basically the body mass index of individual, right? And based on this, we only have like 30% or 25% of the data actually available for us to use. So that is something might be interesting to look at. And then you can see other column is pretty like solid. We have, most of them have data. So now let's move on to, okay, now we have an idea, generally high level idea of how our data look like. Let's deep dive into like different fields, different columns, and really see what in there. So typically there are two kind of, actually three type of data that formats that we typically dealing with. Categorical data, that means like you have some prefix values like female or male for gender, right? And then numerical data means the data is in number, in integer or floats, kind of like format. And the third one is text data, which means the data is more like in natural language kind of format. In this data set, I don't see any text data. We only have categorical and numerical data. Therefore, that's why I just want to print it out, different data type and what are the column in different data type. The reason I want to do this because depending on the data type and data formats, you might have like different data preprocessing and transformation techniques for them. For example, categorical data columns, we have race, pair type, gender makes sense for me. Numerical columns like patient ID, patient zip code, the age, the BMI, and so on and so forth. So now we know what are the columns, the type of each column. So one of the very important initial analysis, what we always perform is to identify missing values, right? So remember the general information that we got here give us pretty like solid information about, okay, which columns that we have a lot of missing value that we need to deal with. But then you also can, instead design like printing a table like this, you can use some kind of visualization, which is like easier to interpret with some people, to visualize the missing ratio, what are the columns that have the most number of missing values and the missing ratio accordingly. So this function that I wrote here to basically to read the data frame, for example, our train or test data frame, and then finding the rows, the cell that have missing value, calculate the ratio, and then just plot it into a bar chart. And what I put here is like, I just want to plot basically the columns that have missing ratio percentage more than 10%. So if the missing value ratio is less than 10%, I'm okay with that. Those columns can be used for downstream machine learning model. But if it's more than 10% missing ratio, we want to do something with it before fitting into machine learning model. So again, when you, one of the coding practice, like best practices, like when you want to run this kind of like analysis task multiple times with different like tables or data frames, you put it into like a kind of function like this. So you will be able to call the function like on different places of your program or your notebook. So that's why I put that particular plotting function, missing value function into a function like this, and then I just call it and run it on our train data frame. So when I run this, basically here are the top 5 columns that have the most missing value and the ratio more than 10%, payer type, payer race, BMI, and then we have some other column. So now I know this might be the one that I need to pay attention for more in the data preprocessing step. So again, and also for categorical columns where we have like predefined value, we want to get a sense of what are the value in this column, right? And again, another better way to do this is to plot it. Like visualization is like just easier to interpret. So basically these functions will read payer type is one of the categorical column that we identify up there, and then count the value and plot the value into a bar chart like this. So when I run this cell, okay, now I see payer type, we have basically 3 categories: commercial, Medicaid, and Medicare Advantage. And then it's look like the commercial make up to like 50% of our data set, and then the other 2 like make up each like 25%. So now we get a sense of, okay, what is in payer type column. Similarly, you can perform similar analysis with other categorical columns accordingly. So for numerical columns, because it's just numeric value, right? Just 1, 2, 3, 4, 5, then it's really hard to like visualize this way into a chart. So normally what we do is just print out the statistical summary of these numerical columns. What is the max value? What's the mean values? The mean value, the standard deviation, the count, things like that. So for example, BMI is on one of the numerical column in our data set, and I just call this function called describe from Pandas, and it will print out the statistical summary of all values in this column for me. So basically in BMI column, you have about 4,000 values available, and the mean of those values is 29, which makes sense because I expecting BMI somewhere in between 15, 10 to 40, I guess. The mean is 14, and the max is 85. This is something a little bit kind of weird for me. I never seen BMI value 85 before. So this might be an outliner that we need to take care of during the pre-processing step. And then the next thing is we also want to try to understand maybe the correlation between different columns, because machine learning algorithm is built based on the features, and the features are here are actually the columns. Each conveys a kind of like different characteristic of your patient, right? The more the more diverse of the feature that we fit into your machine learning algorithm, the better it is, because it's helped the machine learning to learn more scenario, learns the differences, how to react with like a different set of data. So we want to kind of get a sense of, okay, what is the correlation between these features, this column? Are they that informative to fit into our machine learning model, or maybe the information is duplicated and it's not that helpful when you and for your machine learning model in downstream. So this kind of like common and function have you to print out the correlation between the race and the BMI columns, right? So if you run it, you will be able to see, okay, we have different race, Asian, Black, Hispanic, other, and white, and then here you have like different BMI value. And as you can see, like there's no much difference between among different race in terms of BMI. So you might like, I don't know if these are two features are too close to each other and they have the same sense of data. I don't know if that's gonna be informative to you, both of them in our machine learning model. That's something to think about. And then here, I just print out, again, same mechanism. I want to see the correlation between patient race and payer type, right? So I print it out and plot it. So you have different patient race over here, and then you have the commercial different payer type in different color, and then the value, the number of rows affect different categories. So as you can see, we have quite a high number of white patients in our data set. And for white patient, the distribution between commercial Medicaid and Medicare Advantage type, insurance type, kind of like the same. But for Hispanic, we have like bigger portion of Medicaid insurance for Hispanic race. So this is something to tell, right? You see the diversity of your information in your data set, and this might be an indication of these are the two good features to use for your machine learning model training. All right, so that is we done with the the initial analysis of your data set. Again, you can use the same kind of like concept to analyze other columns in our data set. But now that we have like pretty much more or less idea about what is our data, let's move into some fundamental data cleaning steps. And the first fundamental cleaning task that we always perform, I think in 100% of the data sets out there, is to handle missing value. So these are the value. Remember, when we print out, we print out the columns that have like most missing values here. We want to do something with it, right? Either to put the, if it's empty, if it's missing value, we put none NA, for example, like payer type. We just fill in that missing value none NA, or for the BMI, we're missing some certain data, and we might want to like fill in the average, I don't know, the mean number of BMI into that columns. So there's like a lot of technique and strategy for you to deal with missing data. But here I just like demo kind of very basic one. If it's empty, patient race and payer type, which are the two categorical columns. If it's empty, we just fill it with none in A. So once I'm done with that, I just plot the missing ratio bar chart again to see. And then now you see patient race and payer type didn't appear on our chart anymore because we already handled the missing value in these two columns. The next cleaning, very fundamental cleaning step is to filter outliner data, right? Data outliners. So for example, when we did the initial analysis, we saw the BMI max value, which is 85, which is kind of like out of the normal range for BMI. You know, BMI have different, some certain categories, and BMI over 30 will be something considered like max BMI, kind of like high BMI already. So 85 sounds like something very odd for me. So I just do a little bit of like deeper to see is there any outliner in this column by plot the BMI value into a box plots graph like this. So as you see, like different kind of data, categorical, numeric data, you will have like different kind of like charts that you want to use to plot your data, right? And for numerical data like BMI, box plots chart is something very helpful because you will be able to see the outliners in your data. So when I run this, you see, okay, most of our BMI values fall in here in normal range. We have two data point actually is like super like have like out of the range. This is something like 75 and this is the 85 that we saw in the initial analysis. So we want to do something with it. These data will not be helpful. This outliner will not contribute into your machine learning model because it will skew the model a little bit. Even though we only have two outliners, it's not make much difference, but you get the idea. So we want to remove this from the data set. And again, I wrote a function here that you can call a data frame, a table, what is the columns that you want to remove the outliner and the thresholds that you want to use to remove the outliner. And basically you just remove it with this command and then plot again to see if the outliner is still there. So for the BMI column, the threshold value that I set here is 70. And then the outline, I just run that on the train set BMI column with the threshold value and then plots again. And as you can see, now the outliner is gone. And finally, those are like, just now I just presented like most fundamental data cleaning step. There's a lot of others to perform. And you can find all of these tutorial and information about data cleaning online and through some of the online courses. So now let's move to data transformation technique, right? So machine learning module cannot understand numeric data. So for example, it's a text data, you need to convert it into kind of like a numeric representation that machine learning model can take, or categorical data like payer type that we have here. They are actually essentially kind of text data, right? They are string. So commercial Medicaid, medical advantage. So we cannot fit these categorical values into machine learning model. We need to like somehow convert them into numeric formats. So there's a couple like different techniques to do that. Most common techniques are label encoding and one-hot encoding. So label encoding, basically you want to convert these categories into integers follow the order. For example, commercial will be 0, Medicaid will be 1, 2, medical advantage will be 2. One hot encoding is slightly different in a sense that it's not convert the category into integers in order like this. It's more like converting into more binary styles of categorizing. So I will explain what I mean by that in a minute. So for example, for label encoding, right, it's very straightforward. So there's a lot of package library, Python library that can help you to do this. Here I use Scikit-learn label encoder. So you basically just convert these pair type columns into pair type label encode. When you run this command, so you have the original pair type, which are the category here. But then when you scroll down to the end of your data set, you will see a new column added, which is pair type label encode. And then now the string become a numeric number. So 0 for for commercial, 2 for, I think, for Medicaid, and 3 for non-NA, I think so. So you get the idea of label encoding. For one hot encoding is slightly different. It's instead of like converting into integer like this, you try to convert into 1 and 0 in binary kind of like manner. And again, here I am using Scikit-learn label binarizers to do that. And once you run this command line, you will see this is what I meant by binary in categorizing. So instead of generating one column like this in label encoding, one hot encoding generates 4 different columns based on what kind of categories that you get. And then if the value, so you some kind of like binary manner over here. And then I know I'm go over time. I think, Sarada, we have 3 more minutes, right? Do we?
Yes. Please,
Okay.
please go ahead. Please go ahead.
So I almost done. And so that is how we handle the categorical transform categorical data, right? So for other kind of data like patient age, right? We have different age number here, 79 years old, 63 years old. How can we deal with this kind of like very unique numerical but very unique kind of data? So we can do some kind called buckets them into different category, basically convert numeric to category in a sense. So you can define for example, for patient age column here, you can define different bin, right? If 0 years old, it's infant, to less than 2 years old, toddler, less than from between 2 and 4 is a toddler, 4 and 13 is a kid, and so on and so forth. So, and then you can define the labels for each different buckets, and then run this command, this line of code to convert your data into the bucket. So as you see, this is the patient age original column. And then if you scroll down, you see the new column add in and put it, now it convert into different categories, adults, and then you might see, if you print out the whole data set, you will see maybe like old adults in this case. And finally, the final transformation technique, what we call scaling, which is very common too. For numerical values, for example, like home value columns that we have in this data set, it's when you print it out, it's like a bunch of value look like this, and it's hard to make sense of it. So scaling is the process of like converting your numerical value into some kind of a scale, right? Either from 0 to 1 in order for you to understand your data better. So in order to, there's a couple of different scaling technique, but here I just demo min max scaling. Basically, the idea is you get the mean value from your column and the max value from your columns, and then convert all of the other values in these columns based on the ratio between the means and max. So if you run this, and I put that into a function, and then I just run that function on the training set with the home value column. And then when you print it out, the new home values column, you will see like the number that you see here now convert into a scale like this. So you will be able to make sense of, okay, for the second patient, the home value is like 50% in the market, and the third patient is just 10% of the home value in the market. So those kind of things. Now you'll be able to make sense of your data better than keeping kind of like numerical data like this. So again, this notebook, I just really scratched the surface of what are the most basic fundamental data cleaning steps and data transformation techniques that can be used. And it's really tailored for this particular data set that we are going to use for WiDS Datathon 2024. There's a lot of other techniques and also libraries, coding libraries or package that you can use for such purpose. So yeah, I hope that it's this workshop remind you, basically bring you back to a very basic and fundamental topic, peers anything else, any fancy machine learning model. Yeah, and I hope it's helpful in some sense. Thank you for listening.
Thank you, Kelly. That was fantastic. You really covered important and fundamental concepts in tremendous detail. And I'm sure these are things that we all have to deal with when we're building a machine learning model. And I'm sure I can tell from the chat, people found that super helpful. There are also some questions, and we'd like to bring those questions forward. So I think if it's okay, I will cover these questions. Dalia Alrayas, she asks, can we consider data encoding as a part of data transformation?
Definitely. So that's why when I started to prepare for this this workshop, I didn't like it's so data processing is the umbrella concept on top of all of these tasks, right? As you can see in this. So data pre-processing will include data cleaning, data integration and transformation, and data reduction. So it's really an umbrella concept on top of this, and data transformation is inside. There's in the real world, in the real life, in the realities, there's like no clear cut between data cleaning and transformation or pre-processing, right? Sometimes you clean your data, you transform it into another format, and you clean the data again. So it's a really like back and forth kind of like process. So yes, definitely encoding is one type of like transformation, but also pre-processing in a sense of your data.
She also asked, do you recommend eliminating the data feature that has only 24 data entries compared with the total 12,000 data record?
Yes, definitely. These are all like very good questions. I didn't like, again, because of interest of time, I didn't really have chance to like deep dive into the data set. But the rule of thumb is with handling missing value, you don't want to deal with the columns that missing too much value. Because if you fill those missing value with none and a or zero, it will skew your data. It will affect badly to your machine learning model downstream. So if the ratio is just too high, if it's like 24, only 24 rows available, then yes, definitely just not consider and remove it from your data set, because you don't want to fill the rest like 11,000 row with none and a, and it's gonna skew the whole machine learning model later on.
That's true. Yeah. Josephine Fafekafui asks, what method of handling missing values does filling with NA fall under?
So it's filling missing value, I guess. More like not data reduction. So for missing value, there's a couple of like different strategy, right? With the one that missing not too much, the ratio is okay. We want to fill the none and eight we call filling missing values, I guess. That is it. Or we want to reduce, like data reduction. We like back to the previous questions. If it's the missing ratio is just too large, then we don't want to fill the value anymore. We just want to remove it. So
that's great. Ugochi Okengwu asks, I noticed we have 83 columns. Why are you using BMI and payer type variables only?
Yeah, so again, this is a big data set and it's have a lot of interesting thing for you guys to review during the datathon. For the interest of the workshop, we only have like 45 minutes to run through all of these topics. I just pick like the one that I found like, okay, interesting and there's something to talk about. But I'm sure that if you decide to join, and I encourage you guys to really to take part in the WiDS Datathon, when you really like put your hand into this big data set, you will find a lot of other things, interesting things to tackle. So
Nivi Venkat asks, a question for Kelly, for the BMI outlier, instead of removing the rows, can we not impute those two with median values and retain those two observations?
yeah, definitely. So again, this is very similar with the handling missing value, right? So each of the data cleaning step here, handle missing value or filter data outliner, there's different technique. So for filter outliner, also there different technique and different strategy, right? You either can remove the outliner like what I demo here, or you can just fill those outliner with some like median or mean values that you know that is not gonna like affect and skew your machine learning model later on. So depending on the nature of your data set, you might want to apply different strategies. The strategy that I have like demo here is just one of them. It's not the only thing that you can do with outliners.
Anirudh asks, can you please explain the one-hot encoding, like how exactly is it used?
Okay, this is a very good question. I know I was run out of time, so I can't like cross through it like pretty fast. And this is actually one of the most fundamental and important technique for machine learning, because it's literally convert your data into numeric data for machine learning model, right? So for label encoding, I think it's kind of clear in a sense that let me run it again. You basically just convert these categories into numeric, which is this column 0, 2, 3, 1, right? There's a disadvantage of using label encoding is that it's contain potential bias into your data set. For example, if we convert medical advantage into number 2 and then commercial into number 0, so when the machine learning machine is not human, so they don't understand the semantic meaning behind, okay, 0 is actually commercial, people need to pay the insurance company, and Medicare Advantage is number 2, which is government pay for them. Machine cannot understand that. It's only see 0 and 2 in the data set, and it's understand and it think like, okay, 2 is a number and it's greater than 0, so you will treat it like more something like greater or better. I don't know. So there's some potential bias when you do that kind of like converting using label encoding. One-hot encoding is a technique to address those kind of potential bias by, instead of like convert into 0, 1, 2, 3 that contain potential kind of larger, or the notion of larger or lesser kind of like a concept, you convert into a binary format. So if this row, the first row is commercial here, you basically generate 4 columns for 4 categories of payer type. And because it's commercial, so it's 1. That means this is a value, and the other will be 0. If it's Medicaid for this row, it will mark it at 1 and the other value will be 0. When you feed this kind of binary format into the machine learning model, there's no bias at all. If it's 1, that means it's commercial. It's like the meaning is that column, commercial column. And if 1 here, that means it's meaning Medicaid. So there's no potential kind of like misunderstanding of the data using one hot encoder. So I hope that it answers your question.
Yeah, there's actually another question on that line from Iram Akhtar saying, for one hot cone, do you think it could be thought of as a dummy variable approach?
Yes. So I know that it's, I think, yes, dummy variable approach is kind of along those lines too.
There's another question from Marcel who says, I struggle to visualize my data set of more than 7 million rows. What solutions can you propose me when we work with a large data set?
Oh, that's a very good question. So when it comes to like big data sets, your code, like to optimize your code is something very important. We lucky for WiDS Datathon data set that I demo here. It's not that terribly big, so it's easy for me to run. Some rule of thumb is like always like optimize your code, right? You don't want to run through like put it into a loop and then run the whole plotting plot function on every single row in your data frame. If it's 7 million row, it's gonna like take time. So you might want to use some kind of like built-in function that treats the data frame as a whole and save your memory. So some kind of like optimization technique that can be done there. And also be smart in terms of what plot to use, right? Plotting like different type data format, you have different type of visualization. For categorical data, line chart will not work, right? Bar chart makes sense. You have each category is 1 bar in your charts. For numerical data, line will be good. You see the trend up and down, or time series data up and down trend, or box plots like I show in the outliner part, the BMI thing here. We will be able to see the median, the mean, the standard deviation, but also you will be able to spot the outliers. So be smart in terms of like which kind of chart and visualization you want to use corresponding to your data format.
On that note, Anu asks, can we use Apache Spark for data preprocessing, or is it overkill for this data set?
Oh, no, Apache Spark is like perfect for this kind of data set too. I mean, like, well, if you have it available, just use it. By no means, it's fast. And the thing with Spark is it's also allows you to connect to the database. So here we use Python purely to perform analysis, right? Sometimes if you want to jump to SQL query and perform more like SQL, you're more familiar with SQL, then you can use it.
Yeah. There are some questions about outliers. Ayushi asks, what are different ways we can create outliers? Do we just drop the records that have outliers? And then there are other questions, what about outliers and your thoughts on them?
Right. So this is like very similar with the question that we had just now. For again in this within this workshop, I only demo one strategy to deal with outliner, which is just remove it. And because we only have 2 data point that we found, here, so remove 2 rows in 12,000 row will not hurt my data set. But there's a lot of other strategies to deal with outliner. One of them is I think one of the participants just mentioned about like change the outliner to the mean or median values, right? So instead of 85, we change it to 29, which is the mean BMI in this data set. The reason why we want to use median and mean because it's not going to skew our data set, right? If we use the middle point of your value, it's not going to like hurt the the performance of the model. It's not gonna like conveys different messages to the model later on. So you can search for outliner, data cleaning, or data preprocessing, handling outliners. There's a lot of other strategy and techniques.
Yeah, I think we're almost done. There's just one more question that I will ask, and then we will wrap it up here. There's one question that asks, can you throw light on when data scaling is done? I know it kind of evens out that. What is your sort of thoughts on data scaling?
So data scaling is like a technique that's because in the end of the day, the machine learning model algorithm just want to learn the correlation between features, right? Want to know, okay, for example, to predict time duration to the first treatment in our data set, the machine learning model just want to look at different characteristics of the patient, from race, from gender, house value, things like that. It doesn't care about what is the actual value that here. Sorry, I already changed it. So the original value is like very bizarre, like you feel, and you cannot make sense of it. You cannot get a sense of the correlation, the scale of like those value within your context. So scaling is a transformation technique to convert something look like very irrelevant to something more relevant, and you can integrate the correlation, right? By looking at these kind of like scale number, you will know, okay, for patient one, the home value where she lives is actually 50% around somewhere in the middle of the general home market. And the third patient where she lives, the home value actually very low. So this might convey some kind of like message and can be a feature that inform your machine learning model downstream.
Yeah.
Right?
Yeah. Well, thank you very much, Kelly. That was outstanding. It was fantastic. A very detailed, very thorough answers. I really appreciate that. And thank you for audience for asking really, really great questions, really hands-on questions. I think this was a great session. And thank you all. We're ready to wrap up and ready to conclude this today's upscale workshop. So thank you all. And we will share the recording and resources within the next week. I know there are a lot of questions online about that. So I just want to say thank you and join us for the next WiDS Datathon Challenge, which is now open. During this challenge, we will look at how climate patterns impact access to healthcare utilizing Gilead's oncology data set that Kelly showed you in today's workshop. You're welcome to join whether or not you participated in the first challenge. On behalf of the WiDS Workshop Committee, thank you all to the instructors and those who helped organize today's event. Today's workshop was hosted as part of the weekly WiDS Upskill Workshop series designed to upskill data scientists and aspiring data scientists worldwide. Next week in the WiDS Upskill Workshop, we will hear from Sanduni Jayasundara, who will deliver the workshop Machine Learning Basics. Please let us know what you thought about today's workshop by filling out a short attendee survey. We'll post a link in the chat. If you are interested in giving a WiDS workshop on a topic that you are passionate about, technical or professional skill building, we invite you to apply to become a WiDS workshop instructor by filling out a brief speaker application linked in the chat as well. Thank you all for joining us today, and we look forward to seeing you at another WiDS Wednesday Upskill workshop. Thank you all.